Hello, it's Mrs. Green, and this lesson is called Quadrilaterals and their area. So this is a pretty big word, quadrilateral. Sometimes I like to abbreviate it with the word quads. And you might be able to figure out a little bit about quadrilaterals from my graphic. And that might help you with your prior knowledge. So you're writing down what you know about these shapes. And then we'll move on to key information. Okay, two pieces of key information. We have quite a lot of key information in this lesson, but first I want you to define a quadrilateral, and that's a closed figure with four sides that are line segments. So let's do the classic, and then there are pictures of 6 different quadrilaterals in my graphic. So one of the classic quadrilaterals, probably the father of all quadrilaterals, is a rectangle. And so I'm going to indicate that it's a rectangle by putting 2 right angle indicators. And that's got 4 sides. And what it means by line segments is you can't have 4 sides where one of them would be like a curve, like that. That doesn't count. And you also can't have an open figure, so you can't have 4 sides that are open like that. These are non-examples. And I guess that's it. So it's a closed figure, which means it closes on itself, even though mine has a little opening there. And the lines are all straight lines. There's no curves. Now the diagonal, the next definition is a diagonal, and that's a segment that joins 2 vertices. So remember, the vertices are the places where 2 of the segments come together. Corners is another word for them. But it's not a line, it's not a side. So we've got 4 segments already, but those are all sides. So the diagonal is going to go from one vertex to another vertex and join them, but it's not one of the sides. So that's a diagonal. It kind of looks like a diagonal. It's going across in a slant, so it kind of goes with its name. And we can use that for information because we want to know that the internal angles of a quadrilateral add up to 360 degrees. So let me type that. So that's another piece of key information I want you to have in your notes 1, 2, 3. And you should know this from prior years, but we'll recall that the angles inside a quadrilateral total to 360 degrees, and we can use a diagonal to prove that because we know that a triangle has 180 degrees. And we can see from our picture that we have 2 triangles. So the number of triangles inside your polygon, if each one of them has 180 degrees, then you can add those up, and that's going to be the total of your internal angles for whatever number of sides you have. In this case, we have 4 sides. So it's 2 triangles. Each one of them is 180 degrees, and that totals to 360 degrees if you add them together. Okay, so then next piece of key information. Okay, I want you to draw a diagram similar to the one I have on the screen here for your next piece of key information. And there's also a diagram like this in your textbook on page 478. So if you can't read this or you don't like it, there's a different diagram on page 478, which is actually a table. So it's got the properties listed, and then it's got pictures. And if you'd prefer to make a table, you can go to page 478 and get the information. Or you can make this flowchart diagram, which has the information underneath the name of the shape. I like the flowchart a little bit because what it shows is it starts with quadrilateral, and then everything below that also is a quadrilateral. So we've got 2 things happening. We have the trapezoid, and we have the family of parallelograms. And then underneath the parallelograms, we have various parallelograms, but they're special. So we have a rectangle, a rhombus. Those are also parallelograms. So as you go down the diagram, the shapes retain the properties of the shape that was above it. So rectangles also have 2 pair of equal sides. Rhombuses also have 2 pair of equal sides. And then if you come further down to the square has its own properties, but it also has the properties of a rhombus and a rectangle. So I like this diagram, but if you'd rather have a table, you can go to page 478. So this needs to all be copied in your notes. So pause or do whatever you need to do. I'll read off because it's a little bit hard to read. So you've got quadrilaterals, that's 4 sides. Trapezoid has 1 pair of parallel sides, so we're going to mark parallel, we mark with a little arrow like that. So the top and bottom in that case are parallel. You can see the 2 sides aren't parallel. A parallelogram has at least, it has 2 pair of parallel sides, so that's a single arrow and a double arrow. A rectangle is a parallelogram with 4 right angles. So that's the, in order to be a rectangle, you have the properties of a parallelogram, but also 4 right angles. And you can see the parallelogram is slanted. It doesn't have the right angles. A rhombus has equal lengths. So that's congruent, that little symbol. And then a square has both the properties of a rhombus, so the sides are all equal. And it has the properties of a rectangle, so it's got 4 right angles, which most of us know the properties of a square, but we don't always remember that those are also the properties of a rhombus and a rectangle. So the square has the most properties of anybody. Okay, so you need to copy all that. And moving on. All right, let's talk about the parallelogram, and we're going to talk about how to figure out the area of the parallelogram. I assume that you know the area of a rectangle, so we've talked about that, and that is base times height. So that's the area of a rectangle, and everything is related back to that. We had a triangle, which was 1/2 base times height. So super related. It was 1/2 because it's cut in half. It's half of a rectangle. Now we're talking about a parallelogram and how is that going to be related. And we can tell that if we chop off the side, so a parallelogram looks like a tipped over rectangle. So you've got a base, and I could have had the base, could have been this top part also. Like a triangle, you can choose whichever side is your base. And classically, they want the bottom to be the base, but the top could also be the base. It's one of the sides that's parallel. Or actually, the other 2 sides are parallel to each other, and those could have been the base as well. So once you choose your base, then you're going to have to determine your height. And since the sides of a parallelogram are not going straight up and down, they're not perpendicular. This side here is not. See, there's no little right angle. It's not perpendicular. So you have to draw a new line coming down from the vertex. So same thing with the triangle. You're starting at a vertex, and you're coming down, and you're parallel to the base. Sorry. Perpendicular to the base. I'm sorry about that. That's really bad. So as long as your line comes from a vertex and is straight down and is perpendicular to the base, then that's considered your height. So we had the similar concept in triangles. Once you know what that is, the distance or the length, so let's say it's a 5 and your base is 11, then you can use those numbers. You can't use the slanty side, so you can't use this. If this is 6, you can't say that the area is 6 times 11. You're going to use the 5, so you can't use the 6. And the reason for this, why it works, is if I were to chop off this triangle that's sticking out past my height of my parallelogram, if I were to chop that off and move it, it would fit perfectly in this area right here. Can you see how those are the same size? This always works with a parallelogram because of the parallel lines. So those purple, so if I take it and I move it over here, what I've created now, if I highlight it in blue, is a rectangle. So that's going to have the same area as my parallelogram. So now I'm back to the formula for a rectangle, which is the same as the formula for area of a parallelogram. It's so handy. It's base times height. Because my base now goes from here to here, which is the same as here to here. And my height goes up and down. So it looks just like a rectangle whose area would be base times height. So that's how the parallelogram works. You don't have to memorize a new formula, yay. You just have to see that you can change a parallelogram easily into a rectangle. Next. Okay, now we come up with kind of the funny shape that's over to the other side of our diagram here. We dealt with parallelogram, and now we're talking about trapezoid. So let's talk about area of a trapezoid. So there's a formula for area of a trapezoid, and here's my diagram. Base 1 and base 2 are labeled because they're not the same length. One is shorter than the other one, and that's always the case with a trapezoid. That's the definition of a trapezoid, that two lines are parallel. The other two lines are not parallel, so your bases are going to be different lengths. So you're always going to have a base 1 and a base 2. So the formula for area of a trapezoid is if you take the bases and add them together and divide by 2. So you're basically figuring out a line that's halfway in between. Because if you take base 1 and multiply it by the height, you're going to get too big of an area. You'll get this area. You'll get this rectangle, which is way bigger than your trapezoid. You'll get this whole area. That's what you would get if you multiplied base 1 by height, but that's too big. And if you used the smaller base, you would have this area here. You'd only be accounting for base 2 times height, so that would be the purple. That's too small, so then you have ignored these two sections. So you can't take base 1 or base 2 by themselves. You have to average them, which is the same as saying, let's take a line that's right in the middle, and that would be a better line. It's halfway in between. The way you calculate that is to add B1 plus B2 and divide by 2, and then you're going to multiply that by H times H. So another way to show that, so I need you to write down the area formula for trapezoid. So area of a trapezoid, why is my pen not working? Go. There we go. Area of a trapezoid is base 1 plus base 2 divided by 2 times H. Now if you want to write it H times base 1 plus base 2 divided by 2, or 1/2 in the front, those all work. They're all saying the same thing different ways. I just want to do another illustration of why this works on the next page. So write down the formula and then we'll watch to see why this works. So if I take my trapezoid and I duplicate it, make another trapezoid, and then I rotate it, I can make a parallelogram. Oh, it's going to shoot. Well, okay, so here it is, down here. And I want to make a parallelogram. And we know that area of a parallelogram is base times height, just like a rectangle. And so if I were to slide this, you can kind of see, it covers it up because the way the graphic is, but you can kind of see how that would be a large parallelogram. I'll fill it back in. These had, that's how it looked underneath. So that's a large parallelogram. And the base now is B1 plus B2 on top and on the bottom. So if I did the parallelogram area formula, which is base times height, in this case I would have height, which is H, times B1 plus B2, which is my base. But that would give me the larger, the whole thing, which is too big. I only want half of it. I only want to go to here. So that's why we divide by 2. So that's another way to look at it. The one thing I didn't talk about was the height. It's very similar to what we've been saying about parallelograms and triangles. It has to be perpendicular to the base. It's perpendicular to both bases. So you can't use the slanty line. You have to use the up and down a perpendicular line. And then they'll give you a value for the height. Okay, so let's do some let's see if I think that's it. Let me check. Yes, that's it for key information. I'm going to move on to example problems. Okay, example 1 is a pretty bad drawing of a quadrilateral. So it's got 4 sides, 1, 2, 3, 4. And they want you to find the unknown angle measure, which is x, and recall that the total has to be 360 degrees. And they've given me 3 angle measures already. So what I have is 129 plus 120 plus 51 plus x. If all of those added together, those have to total 360. So I can use my powers of solving equations and figure out what x is. The first thing I'm going to do is I'm going to add these 3 numbers together. And I'm going to get 300, I believe. And I still have an x and a 360. And so I'm going to subtract 300 from both sides. And that gives me x equals 60. So those would be my 4 angle measures. Let's just make sure. So I've got 129 and 51, that's 0, 180, and 180, that's 360. Okay, that works. Okay, we have a parallelogram, and I've asked us to find area and perimeter. So my first instinct is to write the area formula for a parallelogram, which I know is base times height. And I have to be careful because I can't use the 2 sides together because they're not perpendicular. It's a parallelogram, so I've got these corners which are not perpendicular. So I have to use the base. Now this is a little bit unusual that I chose this one on purpose because the 2 sides I can use, a lot of people are going to want to use this 11 inches because it's on the bottom. But if you'll notice, nothing is perpendicular to the side that's 11 inches that I'm highlighting here in purple. Nothing is perpendicular to that side. There's no line touching it at a right angle. The 2 lines that are at a right angle are the 8 and the 10. So I have to use the 8 as my base and the 10 as my height. So let me fill those in. Once you figure out what to use, then the math is pretty straightforward. 8 times 10, that's 80 inches squared. That's my area. Now, perimeter is a little bit funky because I have to fill in some of the sides. And I know in a parallelogram, my 2 opposite sides are congruent. So this is 11, and then the ones that cross are 8 and 8. So now I can add up 11 plus 8 plus 8 plus 11. So that's 22 plus 16, so that's 38 inches. All right, so those are my 2, my area and my perimeter. Example 3. Okay, so let's do a trapezoid now. And let's do area. So find the area of this trapezoid, which is the top of my desk. So you can see that one side is parallel to the other side. You have a pretty good understanding of a table that looks like this. It's not a desk, it's a table, I guess. And then the other 2 sides are not parallel. So let's say the red sides are parallel. And even though it doesn't look perfect in my drawing in the picture, and we know what these tables look like. So those 2 sides are parallel, the blue sides are not parallel. So the area of a trapezoid we know is going to be base 1 plus base 2. I have to average the bases, add them together, divided by 2, and multiply by the height. I don't have to have that dot there for multiplication. All right, so they didn't give, I don't have the numbers on here yet. Let's say the small base is 2, the larger base is 4, and then the 2 sides aren't going to help me because neither one of those are perpendicular to my base, my bases. I have to have a line coming down that's perpendicular to my bases, and let's say that's 3. So I'm going to average my bases. So my area is going to be one base, which is 2, the other base is just 4. It doesn't matter which one is B1 or which one is B2. So B1, B2, and then divided by 2 times 3, which is my height. So now we're going to simplify that. 6 times 3 divided by 2, which is 18 divided by 2, which is 9. And it didn't say what it was, but let's just assume it's feet. So 9 feet squared for my area of my trapezoid. 9 feet squared. All right, so find area and perimeter of these two parallelograms. Hopefully you can read all the dimensions. Be careful with your height versus the slanty side. And then two more on the other page. This is 1 and 2. All right, and the last two practice problems, find the area of these two trapezoids. And then write your wrap-up summary, and you will be finished.